Okay, hey, good afternoon, everyone. It's great to be here. So, I like to think of technology as a little bit like a Ponzi scheme. And I will back this up with a quote from Malcolm Gladwell about his father. If he doesn't understand something, he just asks you. He doesn't care if he sounds foolish. He will ask the most obvious question without any sort of concern about it. So he asks lots and lots of dumb, in the best sense of that word, questions. He'll say to someone, "I don't understand. Explain that to me." He'll just keep asking questions until he gets it right. So Gladwell argued that his father would never have fallen prey to the famous Bernie Madoff Ponzi scheme, because when presented with the idea and the investment documents, he would have said again and again, "I don't understand. Explain that to me." And because he couldn't understand it, he wouldn't have invested any money. I think that this curiosity is a thing in our field, represented by this spectrum. On the left, we have the hare. These are the devs who say, "I don't care how X language feature works. I'm going to use it and I'm going to ship," much to the dismay of the tortoise on the right. So on the right is the tortoise. These are the Malcolm Gladwell's father. These are the devs who say, "I want to know more about that. Explain it to me," much to the dismay of the hare. Both kinds of programmers build amazing things. So I'm pretty far on the Gladwell side. Maybe you have a person like that on your team. They spend a lot of time saying, "Whoa, whoa, whoa." They like to break things down, draw on a whiteboard, and write docs. So hello, I am Jake around the web. I am J.W. Worth. I work at HashRocket in Chicago, and for the last 5 years, I've been working on a site called Today I Learned, which is a daily record of the learnings of my team. And I write on jakeworth.com. So back to the spectrum. It maps with an idea that I call the Tower of Abstractions. This is something Steve Jobs talked about many times. This idea that we're all building on the 23rd or 400th floor of a tower. All the work that our predecessors have done are the floors beneath us. Sometimes they are conceptual floors like ideas, and sometimes they're physical floors like a microprocessor. Having these floors gives us an incredible power to innovate, and we're meant to ignore the floors beneath us. I think this is a genuine way to look at software, but I also think that there's room in technology for people who are like me. People who see all these floors and start asking questions about them and say, "I want to know more about that," over and over again until they get it right. So a floor that I've been pondering for over a year are React hooks, specifically the state hook. This is the state hook, use state. The prefix is use, which is the mandatory prefix for any React hook, and that's followed by state, which is the thing that you get and then the thing you can control. It seems pretty simple, but I think it's probably not so simple on a lower level of the tower. And that's what I want to talk about today. So I'll start off with a question. Who is this talk for? Well, React developers, obviously. Raise your hand if you've used React. Okay, great. I'm guessing with that number and the people who are interested in React, we got most of the room. So that's all of you, and nobody can leave. New or seasoned, I'm really glad you're all here. So outside of JavaScript, I hope this talk appeals to people who just like trying to know how something works. And I have a disclaimer as well. You don't need to know any of this to use hooks. I hope when I finish, though, you'll be glad you stuck with me. So back to the thing that I want to know about, the word of the half hour, state. I have a couple of questions. What is state? What is state to React? And why is the way we manage state suddenly changing? This is my pitch. Understanding this hook, use state, will make us better developers. I will make this argument through the following agenda. Part 1, a history of state. I'll offer a short history of state in computer science and React. Part 2, the state hooks deep dive. We'll go into the React code base and try to figure out how this hook works. And part 3, hooks in my code. I'll share some thoughts on hooks today in this particular moment, October 2019. This talk is going to be 66 slides and about 35 minutes. Okay, part 1, a history of state. So in this part of the talk, I want to discuss state from 2 perspectives: state in computer science and state in React. So let's pretend we're in CS 101 and ask the question, what is state? I found a definition online that I think is pretty good. Stateful means the computer or program keeps track of the state of interaction, usually by setting values in a storage field designated for that purpose. Stateless means there is no record of previous interactions, and each interaction request has to be handled based entirely on information that comes with it. So, stateful keeps track, and stateless has no record. It conjures into existence this thing called state, which is the thing we can track. It's a collection of the conditions of the world, and it's the absence of those conditions that makes something stateless. An example of a stateless interaction is HTTP. When I request a web page, the web page is returned, but the web server isn't set up to remember the request. And each piece of information I get is discrete, and it's unrelated to all of the others. An example of a stateful interaction is a browser using local storage to record some piece of information about me, like how many times I've viewed a page on hashrocket.com/blog. So state is such a common goal in programming that we developed imperative programming languages in part to manage them, or to manage it. So what is an imperative programming language? In computer science, imperative programming is a programming paradigm that uses statements to change a program's state. Sort of part of a larger definition. So these imperative programming languages know about and are able to control and change state. In client-server interactions, we know that state is very important. So much that we have this complex architecture, the browser, the storage fields, and the languages in part to support it. So JavaScript has state, and thus so does React. The syntax for React state has changed over time, but I think it's been very consistent. The following patterns at least have been supported: the ES3 module pattern, ES6 component classes, stateless functional components, the class field syntax, and stateful functional components, also known as hooks. I'm going to piece together this history from some release notes and legacy docs. And as I do that, I'll point out that all the code here still works. I've loaded it into a single React 16.8 code demo available here, and it all still works today. So we'll start with React 0.13, which was the penultimate React release before going into the major releases with React 15. React 0.13, or React 13, supported an older JavaScript syntax called the ES3 module pattern. So this is our pirate ship component, and the thing it's going to keep track of for the rest of the talk is cannons count, how many cannons the pirate ship has. So we start off with a function pirate ship. It takes initial props as an argument. This returns an object with 2 keys, state and render. The state key's value is an object, and each key inside of it is the name of the slice of state, and its value is its initial state value. So cannons count starts off as 0. Then we have our render key, and its value is a function that returns JSX. And the JSX can introspect about the state. One of the changelogs I found while doing this research said that this would not be supported and would be deprecated in React, but it still works in the code sandbox I showed. React 13 also introduced ES6 style component classes. So here's our class pirate ship that extends this thing React component. We immediately define our constructor function, and it takes props as an argument. you immediately have to go and call super props. And then we set state using this.state, pointing to the same object. And we're still returning JSX that looks at this.state, but this time it's inside of a function called render. I found a really interesting blog post while preparing this talk by Dan Abramov, where he's discussing what super props is all about, and I'll link to that at the end. So this is a stateful class component as we would recognize it today. When we want to change the state, we call setState. And there are two supported syntaxes. The first is the updater function syntax. Updater functions have access to the previous state and props, and they're therefore able to use that to make a statement. So we're incrementing state of the cannons count one above where it was previously. The second syntax is the first argument object, which allows us to pass an object as the first argument to the function. These functions are batched and asynchronous. React 14 introduced stateless functional components. To quote the release notes from that release, in idiomatic React code, most of the components you write will be stateless. It's a preference, it's a style preference, but I think it hints at where React ended up with hooks. So here's a stateless functional component. So here's our pirate ship component. You can tell by the casing. It takes an argument props, and then we can do whatever we want with the props. Here we're just pulling cannons count off of the props, and then we're looking at that in the JSX3 return. I used to love taking stateless class components and refactoring them into components like these. But I think there's a problem, and that is that props control everything. These components are dumb, and they are therefore less featureful than stateful class components for no really particular reason. If you choose to write this way, you don't have state. So now that we're in the land of ES6, we can refactor stateful components to use the class field syntax. This component is almost identical to the previous class component, except it's setting state in something called a class field object, where we set state and then we point it to our object. Without that explicit constructor function, we don't have to actually write it, and we don't have to call super props. And we can access this .props inside of the object. So this is how the world looked until February 2019. And then a bomb went off. Specifically for this talk, the state hook, but the bomb was the release of hooks. The state hook was described in React RFC 68, and it was released in React 16.8. Hooks were described as a primitive for sharing stateful logic without writing a class. So this is the state hook. We're inside the pirate ship function, and we are calling useState on the third line there. So from right to left, we call this useState function. It takes one argument. That's the initial value of state. And it returns an array that has always two things inside of it. The first is a variable pointing to our slice of state, and the second is our setter function for updating just that slice. You can use useState more than once. Just stack them right up. And if you have more than one slice of state, this is the preferred way of doing it. So sometimes you'll see several of these. So this is the state hook. What have we learned so far? Well, we looked at some state history and theory. We talked about some of the different ways that React has supported statefulness and statelessness. But looking at this code, I still have a question. How can a function have state? I want to know more. So this question is something I will tackle in the second part of the talk. Okay, part 2, a state hooks deep dive, water break. Okay, in this part of the talk, I want to try something. A deep dive into the React code base to try and answer the challenging question that I've asked, what is going on here? I think it'll be a fun chance for us to learn more about React and for me to read a lot of source code in a project that I didn't write. Some stuff here is my interpretation. I'm not sure if I'm going to get every detail right, but I think that's okay. Deep diving into waters like this every once in a while is good for the soul. On this dive, we will encounter multiple packages, type safety, dependency injection, interesting comments, and leaps of faith. So into the code base we go. And as I do that, I will point out that this stuff changes a lot. So this is the head of the React code base that we'll be looking at, which I pulled in early September. Now that everyone has that committed to memory, we will move on. Also, the code I showed today has been heavily edited because it's very noisy, and I wanted it to fit onto slides. So how do we get into the React code base? Well, we call useState. We know about this function now, what its argument is, and what it returns. But where does useState come from? Well, I left a little bit off of the example. Okay, that's better. So we're importing this capital R React and a function called useState from React. That gets us into the React code base. And all the code from here on is going to be React source code. But what is React? Well, in React 14, something called the package split happened. And from that moment on, React has been at least two things. React 14 split React into two things, React and React DOM. And when that happened, React became the package that exposes APIs. Most of the implementation lives in the renderers, of which React DOM is just one. Here is a list of some others. So we have React DOM Server, React Native, and some others. Will this dive take us into a renderer? We'll have to wait and see. Into the React package. So here we find a file called index.js in true JavaScript idiom. Reading from bottom to top, we export either React default or React, allowing for different ways of importing a default. And somebody has left us a helpful comment. At the side on the top level export form, this is hacky, but makes it work with both rollup and jest. And the emoji's mine. Open source rock stars, they're just like us. So we're getting this React from a place called source React. And I'd expect that place to define useState. So for the rest of your life as a React developer, when you are importing React, this is what you're importing. So let's go into source React and try to find our useState. Okay, reading from bottom to top, we export a default object called React. If we scroll up a bit, we see that we define React, and it's full of ES6 object literal parameters, of which one is useState, and there's many others. This is a massive object that exposes all of React, and I've left out a ton of keys, including this little gem. __ secret internals, do not use or you will be fired. It's good to know, but you can't fire me from this talk. Okay, so taking that out, going back, we're importing a function called useState from this place React hooks. It seems like we're getting really close to finding the real useState. Into the hooks. All right, this is it. We found useState. You might notice some different syntax here. This function is type safe via flow. And for those who might be interested, I'm going to walk through that quickly because I think it tells us some things about this function. So we declare useState, and that's followed by a flow function type annotation. And the first thing in that annotation is this less than capital S greater than thing. That's called a generic, and it's not just limited to flow. The generic is a way of capturing the type. We want state to be of many types, but rather than just saying it can be any type, we want to capture what that type is so that later on in the definition we can make a reference to it. So you see the S's a little bit farther down. It's polymorphism for our type system. So then we have our initial state argument, and we say that that type can either be a function that returns something of that type S, and then we have a pipe, that's our union type annotation, meaning it can either be the function or it can be something that just is type S. our initial state, going back to our component, is cannons count, and it's going to be set as 0. So at this point, you might be thinking, I'm not that interested in flow, or I don't really understand flow. The source dive has to stop here. Well, I didn't know flow when I started reading this code, but I kept going. And how did I do that? I found Flow's try flow page. And beyond just validating your flow code, this also provides a flow abstract syntax tree. If you haven't read an AST before, they can be a little bit tricky to read, but the answer to the question, what is this flow code doing, can be found in the AST. So on the right, I've highlighted a generic type annotation, the generics from the previous slide, and that maps up with the last S in line 1, right before the closing parentheses. So that's how I kept moving past this point. Okay, back to the useState function. It seems like we found our useState, or did we? Moving into the function, we see a call to resolve dispatcher, and the return from that, we are just calling useState on that. So we're calling useState, and inside of that, we're calling useState. And this is something known as dependency injection, because we're injecting functionality from someplace else and exposing it here free from all of the implementation details. The React package gives us the features, but it doesn't know how they work. To quote Dan Abramov, "The base class setState implementation has been an illusion all along. It doesn't do anything except forwarding the call to the current renderer. And the useState hook does exactly the same thing." So in this post-hooks world, stateful functional components get something called a dispatcher. And that is the thing that actually implements useState. This useState is an illusion. The cake is a lie. Let's follow this resolve dispatcher and find the real useState. Okay, so here's the resolve dispatcher function. It's a little bit more misdirection because we are calling React current dispatcher.current, and then that's what we're returning. This dependency, React current dispatcher, was at one time called React current owner, which I think helps maybe understand what it does. So we need to go to this React current dispatcher to find our dispatcher. Here's that file. There's not really much here. This is, I think, actually the whole file. Reading from bottom to top, we export a default of React current dispatcher, which we define in the file as an object. It has a key, current, and with our flow union type annotation, we say it can either be null or it can be something of type dispatcher. And that dispatcher type is imported from a place called React Fiber Hooks. I'm not going to talk about Fiber much today. You might have heard of Fiber before. I can just say that Fiber is a data structure, a plain old JavaScript object data structure that's used to manage reconciliation of a component. So it's just work that needs to be done or has been done on a component. So this is a dead end. All that remains here is importing some type. And so I'm not really sure where to go here, but there is something interesting. You might notice that React current dispatcher, the object, is a const. And I think that that can be a little misleading because we know that despite its name, we can mutate that constant object. So here's our immutable object, which we are declaring with the const keyword. And we've given it a key value, and we don't want it to be updated. But then using the bracket notation, we turn right around and update it. So we know that a constant object's key values can be reassigned. So from this dead end, I kind of have to take a leap. Because for useState to do anything, it can't be null. But there's nothing here that tells us when it becomes not null. We're 4 files in, and I still have no idea how this works. Help me, Dan Abramov. Okay, rereading the quote. The base class setState implementation has been an illusion all along. It doesn't do anything except forwarding the call to the current renderer. So we have to go into a renderer. Well, which renderer? Earlier in the talk, I listed a bunch of them. I have chosen to look at React DOM because that's where I spend most of my time. So we know that a renderer can change the current key. My theory is for that to happen, it has to know about the current key. And there's only one file in React DOM that knows about that. It's this file, React partial renderer inside React DOM/server. So we talk about React current dispatcher 2 times in this file. The first thing we do is we set it to something called React shared internals .react current dispatcher, and that sets it to be null, which we know is supported by the type system. Then a little further down the file, we set React current dispatcher .current to be something called a dispatcher prior to rendering, which is something that is imported at the top of the file from this place, React partial renderer hooks. So we need to go there. At the bottom of the file, we export a constant called dispatcher of type dispatcher type. And there's many things in here, one of which is useState. And that comes from the same file. Okay, this is it. This is the real useState. Skipping over the now familiar type annotation, when we get into the function, we see that it is returning another hook. The first argument to this useReducer hook function is basic state reducer. That's an object in this file that tells React you're using the state hook and also allows the initial state value to be a function. The second argument is initial state, which we are saying can be type any. But rest assured, the useReducer we're talking about here isn't some global useReducer, some React level useReducer. It's a special one just for React DOM, and it's also defined in this file. It's a pretty massive function with a big if-else, and it's 75 lines long. So here's the shorter version. This function does at least 4 things, and probably way more than 4, but these are the 4 that I think matter. It creates a work-in-progress hook with that function create work-in-progress hook. Then it sets a key on the return from that called memoized_state. It sets that to the state that it gets as an argument. Then it defines something called dispatch, which is a function. And then it returns both of them inside of an array. So the first thing is work-in-progress hook.memoized_state. The second is dispatch. These hooks are made in this function create work-in-progress hook, which, true to its name, it just makes hooks. How are hooks made? Well, we end up at a function called create hook. Here it is. Okay, so function create hook returns something of type hook, and it's an object with 3 keys: memoized_state, queue, and next, and they all start off as null. So that state is being stored in this JavaScript object. React DOM is just reconciling away, passing around this plain old JavaScript's object's values. So this code from our component, all the way back at the pirate ship component, where we get cannons count and set cannons count, could be thought of as this. Cannons count becomes work in progress hook memoized_state, and set cannons count becomes dispatch. Okay, resurfacing from the code, what I wanted to do in this part of the talk was to try to figure out what is this hook doing. And this is my summary. React checks the types and creates an interface for a dispatcher. The renderer nullifies and then sets a real dispatcher. The dispatcher returns an array of memoized_state and a setter function. And finally, rendering and reconciliation occurs. So that's what's happening. Your functional component state is being passed around in an object inside of React. Okay, on to my last question and the shortest part of the talk. What does it mean for my team to use hooks? Part 3, hooks in my code. In this part of the talk, I want to consider for a minute what it means to use hooks. Because if you use one hook, you open the door to them all. And you can't give a talk about hooks without offering some opinions. So these are my strong opinions. weakly held, collected over a year of using hooks. And I'll start with a summary. Hooks are great, and you should use them. I believe this for several reasons. First, hooks are everywhere. Raise your hand if you've seen hooks either in production or in like books and tutorials. Okay, that's a fair amount to the group. As a consultant, I often work on legacy code. And when that happens, our clients are trying out these bleeding edge patterns, and we often see the results when they come to work with us. Hooks were released less than a year ago, so in my mental timeline, I should start seeing these soon in our client's code. And the window where I get to ignore them is fastly closing. The last React project I worked on launched in the exact same month as when hooks launched. And we wanted to use hooks, but the client wasn't really writing a lot of new code at that point. We were preparing for the deployment and trying to get everything locked down with SEO. So we didn't get to use hooks at that time. I've kept in contact with them, and now they're using hooks everywhere. That's the window that I'm describing. It's closing. And when they come back, it'll be closed. So hooks are currently taking over. Second, hooks solve problems. Hooks solve some real problems that have plagued React. To name a few, first, set state, in my opinion, has always been a problem because it treats state as one thing, one contiguous store. And when you do that, you can write updater functions that are pretty overloaded. With a state hook, you treat state as a slice, much like the way Redux treats state. And I think that that's a clean and scalable way to approach it. Second, it gives you a way to not write constructor functions and still have state. Writing constructor and super props, I think, is a little bit awkward. Third, the two-component syntax, I don't think ever helped anyone learn React, and it led to a lot of pointless refactors. This might actually unify that divide. Another thing is duplicative callbacks can be pretty painful. If you've seen a big React code base, you probably know what I'm talking about. And the use effect hook is designed to try to solve that problem. I could go on, but these are actual problems, and hooks tries to solve them. And I think that's pretty cool. And finally, state management is important. A lot of React code looks at props, and we know that the React core team would like it to be that way all the time. But props can't do everything. And as much as I might try to refactor away state, sometimes it is necessary. A big portion of JavaScript development is dedicated to state management. And I think that's where this idea of JavaScript fatigue comes from. Hooks, context API, Flux, Redux, Undux, MobX. That's all the words I'm going to say, but there's more. State is really important, and we should seriously consider something that tries to make it better. Okay, so say you're sold on my argument that hooks are great and you should use them. Should you go and refactor your giant React code base to use hooks? I think probably not. I did this with some of my side projects last year, and in my experience, reworking existing code into hooks for no other reason than to do that is a bad idea. First, you are likely going to break something. Right? Like any refactor, you have to have good test coverage. And in my JavaScript side projects, I often don't. Secondly, you pay in version control churn. If you're using Git, it can't figure out the refactor. It thinks it's something totally new, and you lose all your line histories. That's a lot of change and a lot of mental overhead for a refactor. And then finally, there's that old saying, if it isn't broke, don't refactor it to use hooks. So once more, I believe hooks are great and you should use them. Okay, today I've talked about state, looked at some code behind the state hook, and offered my hot takes. I argue that understanding the state hook would make us better developers. And I hope I've made a case for source diving your favorite JavaScript library. It's fun, and it makes me appreciate the tower of abstractions beneath me. The people who build these frameworks are really amazing, and they're also human beings who are making decisions that we can understand if we try. I'm very passionate about React. I'd love to talk more with anyone who came here with that same interest. And to the maintainers of React and to all of you for listening, thank you.